Hello guys, today we're going to be finding the exact value of cosine of alpha minus beta, given sine of alpha is 5 over 6 and sine of beta is 2 over 5. And now, additionally, we also know that alpha is in quadrant 1 and beta is in quadrant 2. So in order to find these, we have to use trigonomic identities. And so I have some right here. We're going to be using, since we are finding cosine of alpha minus beta, there's an identity to that. And while it doesn't seem too intuitive, this is just how it is. So cosine of alpha minus beta equals cosine alpha times cosine beta minus sine of alpha minus sine of beta. And another one we're going to be using in a second is the Pythagorean identity. So let's start off with finding cosine of alpha. So cosine of alpha. In order to find this, we're going to be using the Pythagorean identity. Sine of x squared plus cosine of x squared equals 1. And so we know one of these things, it's sine x. So let's put that down. And in fact, let me rewrite this because we're not even finding x right now, we're finding alpha. There you go. And now sine of alpha, maybe I'll do that in a different color. Here you go. Sine of alpha equals 5 over 6. So naturally, sine of alpha squared, wrote that weird, equals 5 over 6 squared. And 5 over 6, in order to square it, we have to square both the numerator and denominator. And that is equal to 25, and 6 times 6 equals 36. So we now know that sine of alpha squared equals 25 over 36. So now let's put that in our original equation. Instead of saying sine of alpha squared, we can now say 25 over 36, and we'll plug in the original variables. Cosine of alpha squared and 1. So we got to isolate cosine of alpha, or cosine of alpha squared. So let's subtract this minus 25 over 36, and we are left with cosine of alpha squared equals 1 minus 25 over 36. Done. But something interesting we can do is change 1 to a fraction. 36 divided by 36 equals 1. And since we're using arithmetic with over 36, then it's going to be easier to add and subtract. So let's rewrite this to cosine of alpha squared equals 36 over 36 instead of 1 minus 25 over 36. And so 36 minus 25 is 25, 35 is 11. 11 over 36 equals cosine of alpha squared. Boom, but we also have to get rid of the square thing. So let's find the square root of this, of both these things. And this, the root of cosine squared is cosine. And as we know, for fractions, we have to do it to both the numerator and denominator. So root 11, I don't know, but root 36, because we can't have square roots in the decimal place. Sorry, in the denominator. But this is pretty easy. Root of 36 is 6. So cosine of alpha equals root 11 over 6. Actually, plus or minus root 11 over 6. Boom. So we found a cosine. And now, last thing. Cosine, or alpha, is in quadrant 1. So as we see here, I moved it over a little bit, but cosine of alpha equals plus or minus root 11 over 6. So if we draw a little quadrant squared. Like it said, if alpha is in quadrant 1. So 1, 2, 3, 4. Alpha is going to be in quadrant 1. And so because it's cosine, we know that in these expressions, I think that's the word, it's going to be cosine sine, right? Or x, y. Since cosine is here, we know that it's positive because it's x. So we're going to draw the little x-axis. Anything on this side is positive. Anything on this side is negative. So, easy way to tell. We now know, and this is the final step, cosine of alpha truly is positive root 11 over 6. Now it is time to find the sine. So now, whoops, there we go, back to where we're, cosine of beta. So we will write our little equation here again, sine squared, and this time we'll write beta plus cosine of beta squared equals 1. Now our given, it says we have sine of beta equals 2 over 5. So I'll write that. Sine of beta equals 2 over 5. So naturally, sine of beta squared is going to be equal to this squared. Now 2 times 2, or 2 squared is 4, and 5 times 5, or 5 squared, is 25. So now we know that sine of beta squared equals 4 over 25. So now we can write this little equation here, sine of b squared, which is now equal to 4 over 25 plus cosine of beta squared equals 1. Let's do some subtraction here. 4 over 25 minus 4 over 25 is 0 on the side. Boom. And we're doing this so we can isolate this cosine. So I'll put here cosine of beta squared now equals 1, which we remember 1 can easily be written as a fraction as, we'll say 25 over 25, which equals 1, just because we're doing arithmetic with another number that's over 25. So cosine of beta squared is now equal to 25 over 25 minus 4 over 25. And that is equal to 21 over 25. Now we need to do one of the last steps, which is squared. So that's pretty easy. It's just cosine of beta, and this is equal to, root 21 over root 25. And these are actually easier, like the last one. I keep switching colors, and it's not consistent, but bear with me here. Cosine of beta equals, well, this is pretty easy because you can't really simple it down at all. But this one is easy because we can. And root 25 is 5. So cosine of beta equals plus or minus root 21 over 5. But now let's look at what quadrant it is. It's going to be in quadrant 2. And it's cosine, so we know from this graph over here, since this is in quadrant 2, we know that it's going to be negative. And the reason why is because if it's in quadrant 2 and it's a cosine, we know that if it's on this side of the axis, it's going to be a negative. So that's a nice little rule of thumb. So finally, cosine of beta equals negative root 21 over 5. So now we can start putting this stuff together. Like we said in the beginning, in order to find cosine of alpha minus beta, we need to use this identity here. This subtraction identity for trigonometry is, in order to find cosine of alpha minus beta, you need to do this right here. So let's write that down. In order to find the cosine of alpha minus beta, you need to do this. Cosine of alpha. What is cosine of alpha again? Let's over here. Cosine of alpha is root 11 over 6. So let's put, I'll do it in green. Root 11 over 6, and it's positive. And we'll multiply it with cosine of beta, which is negative root 21 over 5. And we'll subtract that from sine of alpha. Whoops. This is not supposed to be there. That's a multiplication thing. Whoops. Sine of alpha times sine of beta. And so sine of alpha is 5 over 6 and 2 over 5 respectively. So we're going to be using PEMDAS, obviously. We're going to do these multiplication things first. Here we go. So root 11 times, over 6 times root negative 21. I'm sorry, I'll write that better. Root 11 over 6 times negative root 21 over 5. So we can just go across root 11 times root 21. That's root. And to multiply roots together, you just add them. So that turns into root 31. Whoops. Sorry, you don't add them, you multiply them. So 11 times 21, that equals 231 over 6 times 5, which is 30. And we have to remember it's negative because we're multiplying with a negative. So we'll rewrite that as negative root 231 over 30 minus, and then we'll do the math for this one. 5 over 6 times 2 over 5. That's also 30, and this is 10. 10 over 30, which is 1 over 3. Here we go. But I guess in order to combine these, you would actually have to undo that. So we'll bring that back. So root negative root 231 minus 10 over 30. There we go. Cosine alpha minus beta. Boom. And so that's that. Cosine of alpha minus beta is equal to negative root 231 minus 10 over 30. And here's all the steps we did.